I am Sharath Kumar. I am right now with Asian Paints. I am regional sales manager. I am with the construction chemical industry for 15 years and having overall experience of 20 years. And work right now, as I was saying you, Asian Paints, my previous company was MYK and Sika. I was with Sengoben. And I'm sure there will be some exchange of information. I'm sure I'm going to pull some backbenchers into your attention, because this is an interactive session, not as dialogue delivery session which I just wanted to, or I just want to make it a monologue. I want to make it a dialogue. Hope your participation will be there, and let's make it more subjective. See, since morning we have been speakers talking about waterproofing. I was also having preparation about waterproofing, but then I thought after seeing three presentations from waterproofing, I will only end up boring you. So I am changing the topic from waterproofing to repair and restoration. I think this is one interesting topic, important topic, which every civil engineer will love to hear, understand, and give some solutions to consultants when you actually visit the market. Why does a structure repair? Why does a structure requires repair? Any answers? Why does a structure requires repair? Any answer? See, there are no right answers, no wrong answers. Any answer is the right answer. Or if you say right, probably it is right. If you say wrong, it is only learning experience. So there are no wrongs. Why does the structure require repairs? Especially RCC structure. In form of RCC structure we are talking about. When you design a structure, actually I think engineering says that we design a structure for 100 years. But why does a structure require repair? Maybe in 5 years, 10 years or 15, 20 years. Maybe the time span changes, but then structure will eventually come into a stage where it requires some kind of repairs. Why does that stage comes? I think the answer is quite yes, exactly. Any more answers? Quality of material, right? Practices, construction practices, environment, natural forces. You do not know the climatic changes. You never have seen this kind of rains. You don't design structures for this kind of rains. The kind of climatic changes that we are seeing through, or the industrial pollutions that we are going through, the automobile pollutions that we are seeing. So every factor is driving us towards making the structure something where we have to take it for repair at the early stage than its complete life cycle. See, in concrete, what we have is steel to make it more tensile. You get and the steel is the original form is an ore. So if you leave a steel bar like that, the steel tries to go to its original forms, means ore form. So how does it happen? Steel, what happens is that after you introduce that steel bar into the reinforcement, over a period of time it gets contact with moisture and oxygen. In presence of moisture, the steel has two poles, which is in a latent form, which is always in a latent form. It will have one pole which is called as anodic pole, and another pole which is called as cathodic pole. Anodic pole in steel will release latent electrons, and cathodic pole will start picking up all those electrons. So the moment the electrons are released, what happens to the steel? Steel will start losing its weight or the dimension. So the steel will get corroded from one point, and this is called as pitting. So you should have a medium of transfer. The medium of transfer for the steel here is moisture. If the moisture is there, the medium of transfer is there, and if the moisture is not there, steel does not get corroded. So I would say that to stop steel from getting corroded, you have to either cut the anodic form, or you have to cut the cathodic receptor, or you have to cut the moisture, which in any form we cannot do it in a direct way. So what we do is we try to increase the life of structure by introducing something which is more interesting. That is what we are going to learn right now, so that the life of the structure enhances, and then we can get the full benefit of what we have designed for. Got it? I will talk a small thing about Asian Paints. Asian Paints is established in 1942. I am just reading out from the slides. And we are market leader in construction chemicals. We also market leaders in repair and restoration solutions. We are ranked second in Asia and 8th in world for decorative solutions. And we have turnover of 35,000 crore rupees. We have a huge network of dealers across India. I think Asian Paints is something that it's a brand. As it is said in Pushpa, it's not a name, it's a brand. So Asian Paints, apart from retail sales, Asian Paints has a very strong project sales. So the project sales of Asian Paint is into waterproofing, flooring, repair and restoration. We also provide admixtures. We also provide in situ solutions. We understand how the site is there. We take photographs. We process through AI, and from AI we will get a solution which is AI based solution, which is like you need to understand what is the structure going through and what are the remedial solutions that you have to give. Instead of you interpreting, we have given the job for AI. So AI gives you more accurate solutions as how you want to, how you have to repair the structure. And the brand of construction chemicals in Asian Paints is Smart Care. So Smart Care is the vertical wing of Asian Paints, which is only into construction chemicals. The other paints, we have paints division, we have taps and faucets division, we have sanitary division, we have UPVC windows, we have curtains, we have everything like. Coming to the subject of repair and restoration, what do we have in repair for you? We have 100 plus products, 250 SKUs, and it is like, we have applied close to 1 crore square feet of coating applications like anti-corrosion coating applications, protection steel applications into most of the segments that we are servicing across India. And these are the range of products that we are having. We will run into some important products that will really help us out to understand what we do. Okay, before we get into this, what is the nature of concrete when it is being casted? Is it alkaline or is it acidic? Any answers? What is the nature of concrete when it is casted? Alkaline, right? What is the pH? Okay, it is alkaline when you actually check the pH of concrete on the day it is casted. It is approximately 14. Usually it hovers around 12-13. 14 is what? 12.5 to 13. Yeah. On the day when you cast it, actually it would be the 12 point hovers around 12 to 13. So when a steel is under corrosion, people usually recommend removal of rust on the steel and recoating. And most of the rust removers in the steel in the market are acidic in nature. The moment you put acid on the concrete, the rust gets removed, and you can subsequently clean it with water and then coat it. But what happens when you use acid on concrete, which is already and which one is alkaline, one is acidic, so the concrete does not stay, does not complete its life. So what we have is a material which is rust remover, which is alkaline based rust remover. This is one of the few materials which is alkaline based. So remove the rust remover coating, and then whatever rust is there on the surface can be converted into steel by application of rust coat RB. This converts rust back into steel form, or at least it will passivate any kind of corrosion formation on the steel. So that is one product. So corrosion of production. So rust trim and rust coat RB. So our rust coat RB is a passivator which will convert the steel rust into the steel form, right? Or at least it will passivate it at that original stage. And what we have for the next one, many a times you have seen a corrosion structure. A beam which is under corrosion, can you access onto the rear side which is very well in contact with concrete? You cannot. So what we do is, but if you leave that concrete, if you leave the steel bar without treatment, will you be able to justify the complete corrosion treatment without treating that particular part? No. So what we have in this particular area of operation is, we have some material called as Carpodex system. It is self-healing anti-corrosive coating for steel structures. It is tested for 1000 hours of corrosion resistance, and it has excellent chemical resistance too. So just apply this material on the steel coating. It will self-heal and then get into those areas where it is not properly treated, and then you can go for covering of, these are the areas which I am talking to you about. The hidden areas behind the reinforcement. We have a material called as bipolar corrosion inhibitor. I will show you a photograph. You can see here a material which is exposed to corrosion, and here the rebar which is exposed to same kind of corrosion, but it is having connected with a bipolar, this is a concrete mortar which is packed, and then you can see a bipolar material in this particular thing. So it diffuses into the air, gets in contact with the steel, and then ensures that steel is not getting corroded. This is a bipolar corrosion inhibitor which is used for steel protection. So what you do is, you just spray this material on steel bars wherever it is not reachable, and do your treatment subsequently, so that it is properly packed, and then you will have proper corrosion inhibition for the steel whatever you are using. So That's what we are talking, corrosion protection of unexposed steel bars. So exposed steel bars, we try to remove the steel, we try to use it by rust remover and then apply the rust converter and then plaque it. The corrosion inhibitor is something which on the rear side also you can just, if you spray it on the concrete, on the steel bar, like it will go on to the non visible side and then protects the steel from getting corrosion further. And we also have one more material. Let's say, like, you are seeing that a column or a steel bar is under corrosion. Now there are two ways of slowing the corrosion down. There are two ways of making this corrosion process slower. Either you have to immediately open up and then treat the corrosion, or you also can do something like, I was saying you that steel gets corroded because there is presence of moisture and anode and cathode, right? So when you supply anode, the required anodes to the cathode from a external source by a specific tablet called as from a specific source, what it does is, this specific source takes all the required electrons and then it will passivate whatever anode is releasing, so that anode will not release any kind of electrons and cathode will also be getting passivated. So it is a form of protection which the steel gets properly protected and the life of the concrete gets increased. It is a small tablet that we are seeing right now. What we do is, this tablet is driven into the concrete. It will emanate certain kind of cells into the concrete, and this air gets diffused. I know the diffusion process, right? Where there is high density, where the air diffuses from high density area to low density. So this material has certain kind of density which will be emanated into the concrete, and the diffused air will form a passivation layer around the reinforcement, so that reinforcement does not get corroded and extends the lifetime of the material. So you can also do this for all structures which are 10 to 15 years old or 20 years old, which are, you think, under corrosion or going to get under stresses. So this is one material for you. So what do? You scan the rebar, whether the steel rebars are there on the particular area or not. If the rebar are there, you have a rebar scanner, use rebar scanner and try to find out, and then subsequently go to that area which is not where the rebar is not there, drill it 30 mm deep into the concrete. Yeah, drill it 30 mm deep into the concrete. Once it is drilled, remove the dust and everything, put this cardboard up inside, seal it with epoxy putty. So this will diffuse whatever electrons are there, so that the steel life enhances. So it is something like, you have to put it at every 1 meter center to center on a particular area, so that the entire column is being protected for a long time. You have an enhanced life. 3 caps. Depending upon that also depends depending upon the kind of intensity of corrosion it is having. If the intensity of corrosion is severe, probably you will have to place it closer. If the intensity of corrosion is just in a starting stage, place it at a longer distance. A small hole into the concrete will not make it, because either way we nail the concrete, we do all the kind of abuse. So it is properly getting sealed subsequently. It is 20 mm dia. The capsule size is 20 mm, so you will have to make it 22 mm dia kind of hole, almost 1 inch. It is a pungent alkaline smell which I have seen myself. So it is also alkaline in nature, it is not acidic, so that it will go and protect the concrete in a proper fashion. Steel is corroded or not? Okay, you can see the structural unexposed surface. Like steel, what happens when it is getting corroded in initial stage, you will see some cracks, because steel, when it is under corrosion, increases volumetrically. It can go up to 6.5 times its original size, but then on second volumetric or 1 point, when it increases by 1.2 times, you can see clearly concrete spalling itself. It can increase up to 6 times. I mean 1 mm can become 6 mm, but does not volumetrically. So weight will remain, or it will even further deteriorate also, like yeah. The concrete, you will see all the kind of stresses, because it starts pushing concrete outside, right? When there is a volumetric expansion in steel, it will start pushing the concrete. The core concrete is only 25 mm. It does not have tensile. It is only compressive in nature. When it is pushed out, you can see cracks. When you see cracks, probably then you can start working on this particular area. Sack node, or you are talking about? Yeah, this Carpodab is tablet is post concrete, and this product which I am talking to you about right now, which I am going to talk to you about right now, is during concreting. Sack node. So sack node is sacrificial anode. What it does, I will show you a photograph, which is a live photograph taken at our laboratory. This is some. This is casted in 2016, something like year 2016. To the two steel bars, we have a conductive zinc cathodes which is connected to the steel bars and exposed to 3.5% sodium chloride solution, which is a seawater kind of this thing. So when you expose this, the steel starts getting corroded, and you leave it. The steel bar, which was in 2016 like that, when I went there a couple of weeks back, has become something like this. So in exposure of steel, steel will get corroded so much and nothing will be left over for the structure. So in high intense corrosive areas, I am talking to you about industrial areas, areas that are having very severe ground pollution, and which are nearby lake beds. I think most of the lakes are right now polluted only. So go for this kind of sacrificial anode, which is tied to a steel bar at that point of time. This sacrificial anode will start emanating required anodes to the steel, and steel will start taking whatever is required from this rather than getting corroded. So what will this do? If the life of the concrete is without this is something like 20 years, this will increase your life by 20 years. So 40 years is what you are absolutely assured. And what will be the cost of it? 400-500 rupees once sacrificial cathode. So you don't have to demolish your structure. The structure can remain, and you can perfectly be assured that nothing happens to your structure even in most corrosive environments. So what we do, this is tied into the concrete at the time of construction itself. Put it and pour the concrete, nothing happens to it, and the life of the concrete, the life of the structure is definitely ensured. That is the technology of sack node. And what is this low viscous grout? Like, you must have seen like railway structures or railway bridges or beams, columns, everything, like where they will have a lot of honeycombs embedded, and then honeycombs have to be properly packed up with some material. Most of the companies will have this low viscous epoxy grouts with the viscosity of 200 centipoise, 300 centipoise kind of materials. While Asian Paints have introduced this material at 5 centipoise, which is as close as water. If water can penetrate into concrete, this will easily penetrate into the concrete. So what is the advantage of this material? It will force where there is scope of water, it also gets into that, but those crevices where water can get into, and strengthens that area. The compressive strength of this material is close to 80. So 80 is 80 newtons per mm. So 80 newtons per mm square is the compressive strength of this material. So when you actually cast concrete, it is M25 grade or M30 grade. It will enhance the grade of concrete by so much of, like, it will pump in so much, and the viscosity is 5 centipoise as I was talking to you about, and it will really strengthen your concrete, like it is complementing it. And because it is so low viscous, it can get into those crevices and cracks. When you are doing waterproofing for structures, there will be a lot of shrinkage cracks in the structure. These shrinkage cracks have to be, speakers prior to me were talking about structural cracks. I am not talking about structural cracks. The cracks that are shrinkage cracks, that are plastic cracks or other cracks that come onto the structure. So you just do one thing, widen the crack, pour this material, it will flood into the concrete and then strengthen those areas. So this is very, very important material in engineering, in especially repair and restoration segment, for waterproofing segment, and it is to be used. Like, if you are going to replace it, probably yes. If you are not, you cannot replace the concrete, right? What is going to happen is, it will only enhance, the grout will only go into those crevices and spaces which are left over due to concreting. It could be because of honeycombs, the heat may get into honeycomb areas. It may be because of those areas or cracks, it will only get into those areas. But if you actually test the strength in that particular space, it will be MAT. But if you actually test your cube, it will be M20, because that is a failure criteria. You may have aggregate which is of higher strength while you are casting concrete, right? But aggregate fails much, like even concrete cube fails much earlier. But when you actually take that aggregate and test that, the strength of the aggregate will be even much higher. So the failure criteria is designed by the concrete entire RCC or PCC, whatever you are going to design, not this low viscous grout. Low viscous grout will only enhance or complement whatever you have done. On a surface of where you are going to do waterproofing, it will get into those cracks, seal the cracks for lifetime. I will say you one more thing. What happens in the subsequent summer season? Concrete expands and expands into those areas which are already having cracks. If the concrete cracks, what will happen is, like, it will crack in those weak areas first. So the weakest area right now is not low viscous epoxy grout, because we have strengthened this area. If it is a cementitious grout or any kind of mortar, repair mortar you keep, repair mortar does not have such a kind of bond strength which it can hold the slab together. while it can keep the slab stitched together properly, repair motors, regular cementitious repair motors cannot do that particular job. So we recommend usage of this material for most of your waterproofing requirements. We also have two component PU injection grouting materials, which are like they form foam. They also why do foam forming is required? Because there is a huge amount of honeycomb, and honeycombs have to be filled up with some material from external source, which is 2K injection PU grouts. We also have carbon wrapping materials. Okay, students, now you have designed a structure for M30 grade. The client says that now my loading pattern has increased and my design for M30 grade does not stand good. I want to go for higher grade of concrete at this point of time in the same structure. How will you enhance the structural strength of concreting or the columns? Are you able to understand what I am asking? How will you be able to enhance the strength of column without, or what are the various processes of enhancing the strength of column when you want to increase the loading of structure? Retrofitting, right? Any answers from your side? Okay, what you do is, like, when you design a concrete column after M30 grade, like, concrete buckles and fails, like, when you are increasing the load. Is it right? So what we do is, instead of making the concrete buckle and fail, what we do is we confine the concrete, you put further confine your hand, so your hand will become like, can give you extra strength. So when you are injured, you also confine your leg by putting a plaster around, so that the movements are not moved. So this is something like that for your understanding, simple understanding, though it is not that way. So what we do is we confine the concrete by putting a wrap around, which is called as carbon wrapping. We also have glass fiber reinforcement also. We also have carbon reinforcement. There are two types of materials, and put epoxy adhesive around it, so that the load bearing of the structure increases by at least 30-35% or 40%. It will not increase by 100%, and it will not take much higher volume also. So in a short time, maybe we are talking about a 1 month span of time, we can increase the structural strength just by adding or wrapping a structure. I will just show you how the structural wrapping is done. So this is your base concrete. We put an epoxy primer, epoxy saturant, glass carbon fiber. So epoxy saturant is the basic primer we are going to put, and on which we are going to wrap the carbon fiber. The carbon fiber is what you have seen a while before. This is the carbon fiber. This one is the carbon fiber. This is the glass fiber reinforcement. So this is applied onto the concrete column or on a beam by putting epoxy adhesive. Subsequently, we also put one more layer of this epoxy saturant adhesive on top of it, and finally put some kind of sand on top of it, so that and it is broadcasted, so that it is not exposed to environment, and it gives you that kind of required strength in that particular area. So you enhance the strength by confining the concrete and increasing its strength. This is called as carbon wrapping structure. What will you do for a columns? I mean, what will you do for a slab? For a slab, what will you have for a slab? Do you have bending moment? So this bending moment is being opposed, or it is compensated by that extra bending moment, which is because of the extra load, is being compensated by putting what you actually have in the concrete. You have rebars, right? These rebars are complemented by having external reinforcement, which is a glass fiber reinforcement or carbon reinforcement from below. What we do is, on the below structure, we cut the concrete, we put this glass fiber reinforcement, put epoxy adhesive, so that the bending moment whatever you are having is being compensated. You will have a better structural stability there. So it is not just column, we also strengthen the beam, we also strengthen the slab, so that the entire structure is being strengthened for the required strength achievement. This is not a carbon fiber, this is a laminate. This is called a carbon laminate. And finally, one of my previous speakers were also talking about anti-carbonation coatings, protective coatings for various kinds of structures. So we also have most of them. Why is anti-carbonation required? Carbon dioxide gets into the concrete, reacts with iron, takes free oxygen inside, and reacts with moisture, and then starts corrosion. So anti-carbonation coating will ensure that it is being protected for a long time. We also have these anti-carbonation coatings, and glass flake epoxy coatings, which are highly corrosion resistant, especially for corrosive structures, pipelines, sewer pipelines, and so on and so forth, and other corrosion protection coating materials. We also have micaceous iron oxide coatings for severe corrosive structures, and other materials like glass fiber, glass flake epoxy coatings, and other things. We also have heat resistant coatings. Probably it may not make much sense for you, because heat resistance is required for those industrial structures where there is extensive heat coming up from a particular surface, and you have to protect your concrete. If the concrete is next to it, heat will definitely damage the concrete. So we also have heat protection coating on the surface. I wish, like, you should explore your career opportunities with companies like Saint-Gobain, Sika, Asian Paints, where we also offer people like you positions into sales, technical services, where you can be getting into industry. You can see a faster sales career growth, and it can really help you. We are actually running short of people. We are really running short of people. A quality person is always welcome into this particular segment, because in sales, technical services, in back-end offices, probably this is something we are definitely looking forward for. Probably you may also have a good career as a civil engineer. I'm a civil engineer myself, so think about that. I'm more happy in sales than I was in on-site. So explore this opportunity, see as how you can contribute to the country and contribute to yourself in terms of productivity and everything like.